Alright, so in today's tutorial video, I want to look at statistical methods for analyzing pairs samples in R. But before we proceed, I'll urge you to kindly take a look at my previous tutorial video on the flowchart for classifying data, okay? Because in that video tutorial, I have illustrated and explained the data structure for paired samples, which will help you to catch up with everything that I'm going to do in today's tutorial video. You can just click on the link in the card above or check the description of this video for the link, okay? So like the two samples data or the independent samples, we have parametric tests and non-parametric tests for analyzing such data. The same applies with paired samples or paired data, okay? So the type of parametric test for paired data is known as the paired t-test or the dependent t-test. Sometimes it is called the repeated measures t-test, okay? This test basically compares the means of two measurement taken from the same individual object or related unit. Okay, for example, researchers may wish to compare the means of a pre-test or post-test samples in which a factor is measured before and after an intervention, or researchers may wish to compare the means of a crossover trials in which individuals are randomized to two treatments and the same individuals are crossover to the alternative treatment. Okay, so there are certain assumptions which must be satisfied before we can make use of this test. One of the assumptions is that the data must be continuous, and the next one is that the data or the difference for the match pairs follow the normal distribution. Okay, let's take a look at the non-parametric test for paired data. This is known as the Wilcoxon Signed-Rank test. Okay, so this test basically compares the medians of two measurements taken from the same individual object or related unit. For example, researchers may wish to compare the medians of a pre-test or post-test samples in which a factor is measured before and after an intervention, or researchers may wish to compare the medians of a crossover trials in which individuals are randomized to two treatments and the same individuals are crossover to the alternative treatment. Okay, so there are certain assumptions or conditions which must be satisfied before these tests can also be used. One of the conditions is that the data must be continuous, and the next one is that the data or the difference for the match pairs does not follow the normal distribution. Okay, now let's take an example. So a psychiatric hospital performed an experiment to compare whether a record score in which instructions to form images of 20 words were given is better than an initial record score for which no imagery instructions were given. Some patients were randomly selected in the experiment with the results shown in the attached psychiatric data set. Does it appear that the average record score is higher when imagery is used? We want to conduct a detailed statistical analysis for this problem in R. But before we do that, let's quickly take a look at the psychiatric data set in a CSV format. Okay, so here we go. We have the first column being the observations of the individuals, and we have 5 variables here. Okay, so we have gender, age, height, no imagery, and imagery, but we are interested in these two, no imagery and imagery. Okay, so no imagery basically shows the record score for the patient when no image instructions was given. Okay, while this one is showing us the record score for the same patient when instructions or image instructions was used. So it's the same individual or patient with two different measurements, and we want to compare if the average record score is better when image instructions was used. But one thing that you also have to note here is that this measurement is for some let's say it's for two different groups. Okay, if you look at gender here, we have one which has been indicated as 0 and we have another one being indicated as 1. Okay, so let's assume 0 is for the female group and 1 is for the male group. So in our analysis, what you're supposed to do is that we are supposed to determine the average record score for, let's say, group 0. Then we'll do the same for group 1. Then we will do another one for the combined groups. Okay, we have to do one for the combined group. So that's how the analysis is going to look like. So let's quickly jump into our studio to begin. So first of all, you would like to clear all your environment and graphic windows, right? If you have yours clean as mine, you can just skip this line and just proceed to import your data set. So I'm using the read.csv function because it's a CSV file, and file does choose to basically choose from the folder where I have my data file. So let's quickly run this. Alright, so I have my data file here, our pair samples. So I'm going to leave this data file in the description of this video so that you can download it, okay? So let me click on that, open. So once you import your data set, you will have an information in the environment window. So you can just click on here to view your data set, or you can just run this code offline to also view the data set, okay? So let me click here. So this will display our data set in a spreadsheet form like what we saw in the CSV format, okay? Let's go back to our script file. Let's get a structure of our data set now. So we can see that all the variables are integers, but we know that gender is a categorical variable. So in our data manipulation, we are supposed to encode this variable by basically converting it into a categorical type, okay? So let's quickly do that. In R, one of the libraries that can help us to do data manipulation is the dplayer library, okay? This library. So if you don't have this installed, you have to first of all install it. Go to packages and click on install, and make sure that you are connected to the internet and type the name of this to install, okay? I've already done this, so I'm going to skip the installation part and load this. Alright, so we want to now recode the gender from string to numeric, okay? Basically assign some values to the labels. So I'm going to assign my transformation to a new dat. Okay, so for my imported data, I'm using the mutate function here to basically add another variable to my current data set. So this factor function is basically going to convert this gender variable into a categorical type, okay? So let's quickly run this to see the effect. So let's look at the structure of our new data set. So we can see that gender 1 is now a factor with 2 levels. 1 will be assigned to 0 and 2 will be assigned to 1, okay? So we are good to go. The next thing that we want to do is to basically rename and remove some variables, okay? So for my new dat, I want to remove this variable. I'm not interested in this one. I'm interested in the gender 1. So I'm using the minus sign to remove it, okay? Then I want to rename the no imagery as A and the imagery as B, okay? So let's quickly run this. Yep. So we can click on our new data set to see the effect. So I've renamed no imagery, and this one is image, okay? And this gender 1. Alright. So you can also use a table function to view the first 10 observations, okay? Control enter. So we scroll up and see the effect. Alright, so the next thing that I want to do now is to basically try to determine the average record score for the female group, which is group 0, okay? Then we'll do same for the male group, which is 1. Then we'll come to both groups, we'll combine them to see the analysis if we are going to end up drawing the same conclusion or different conclusion altogether, okay? So we're going to start with the first one, determine the average record score for group 0. So what we're going to do now is to filter the no imagery and imagery for group 0, okay? So I'm assigning my data to G0, group 0. So filter the label 0, right? So this is going to help me to get only the female group. Then I want to select only the variable A and B, which is no imagery and image, okay? So let's quickly run this to see the effect. Alright, so I can click here. Yep, so here we go. And the next thing I want to do is to add the difference for the match pairs, okay? We want to add the difference of the match pairs to the group 0 data set, okay? So with a mutate function, we are going to get another variable which is going to be the difference between imagery and no imagery, okay? So let's quickly run this. And let's click on this to see the effect. So now we can see the difference here. So we take the difference for the match pairs. This minus that, this minus that, this minus that, this minus that. Okay. Want to find out if when this was used, the record score is better compared to this one. Okay. So that's why we are taking the difference in that order. So now the next thing that we are supposed to do is to do some expiratory data analysis. Okay, but I'm going to skip that for now. If you want to learn how to do expiratory data analysis, you can check out my video tutorial on expiratory data analysis in R. Okay, you can just check the link in the description of this video, or click on the link in the card above to basically do that. Okay, so before you start with the parity test, you have to basically do some descriptive statistics. Okay, before you start with your main analysis, so you can just check out the video for that. I'm going to skip that and proceed to the assumptions. Okay, so if you go back to our data set, now you can see that these values are already continuous. So the next assumption that we want to look at, we are looking at it for the parametric test. The next assumption is to check for the normality, right? To see if this difference, match pair difference, satisfy the normality assumption. So let's go back to our script file. So in R, to test for the normal in R to test for the normality assumption, we will start with a QQ plot. But with a QQ plot, we need a library that's a QQ plot R. So let's run this. If you don't have this installed, you have to make sure that you install it first. And then the next thing I want to do is to get a QQ plot of the match pair difference for group 0. Okay, so let me highlight this. So this QP0 is basically going to be the data graphic. Okay, my plots, I'm assigning my plot to GP0. So this is the data for the group 0, that is the female group, and I'm interested in the variable that is the difference, DIFF. Okay, that's the static mappings. You are interested in that variable. Then I want to add the confidence bound, the QQ line, and the point. Give it a label. So the x-axis, I'm labeling it as the theoretical quantile, and on the y-axis is going to be the sample quantiles. Then I'm giving it a title here. So this is going to be the QQ plot of the match pairs difference for group 0. Okay, so let me run this together. So Control Enter. So let me go to plots. So after checking the QQ plots, you can also make use of other normality tests like the Shapiro-Wilk test and the Anderson-Darling test. Okay, the null hypothesis for this test states that the data is normally distributed. Okay, but with Anderson-Darling test, we are supposed to get a library known as the not test library. So let's quickly run this. I don't know why it's taking too long. Okay, let me rerun this again. Let me run this first. Control Enter. Try to run this. Alright, so here we go. So you can see that most of the points are on the straight line, and they are also within the confidence bound, sloping upwards to the right. So this is an indication that the distribution of the match pairs difference for group 0 is normally distributed. Okay. Alright, so we want to check the normality test again, making use of Shapiro-Wilk test and the Anderson-Darling test. So let me run this through. This is going to give me the Shapiro-Wilk test, and this is going to be the Anderson-Darling test. Okay, for the pair difference. So let me run this. Control Enter. So here we go. So we can see the p-value for the Shapiro-Wilk test is 0.6273, and that of the Anderson-Darling test is 0.4273. Now if you have to compare this to the alpha level at 5% or 1%, it means that we are failing to reject the null hypothesis. Okay, we only reject the null hypothesis if these p-values are going to be less than or equal to the alpha level at 5% or 1%. But because these p-values are greater than the alpha level or the threshold value at 5%, it means that we are failing to reject another hypothesis and conclude that the distribution of the match pairs difference for group 0 is normally distributed. Okay, so now that we are clear that the assumptions has been satisfied, it means that we can make use of the parametric test, that is a paired t-test. Okay, so how would a null hypothesis look like? So we can state the null hypothesis as the mean record score for group 0 is the same when imagery is used, and the alternative could be that the mean record score for group 0 is better when imagery is used. Okay, in other words, we can also say that the matched pairs difference in the mean record score for group 0 will be equal to 0, and the alternative will be that the matched pairs difference in the mean record score for group 0 will be greater than 0. Okay, alright, so now let's look at the paired t-test. So this is the function that's going to help us to get a paired t-test. So the first argument is for the imagery, right, and the second argument is for the no imagery. So this is the imagery for group 0 and no imagery. Okay, we are doing this so that it can satisfy the question that we want to solve. We want to find out if this one is better compared to this one. Okay, so let me show you this. So this how the null hypothesis will look like. Okay, because in R it's going to take the difference for the first argument minus the second argument. Okay, so in order to ensure that we have an alternative hypothesis in this form, we are supposed to specify the imagery score first before the no imagery score. Okay, so once we do it in this way, we are going to have this alternative hypothesis, or basically in this form, because it will take the difference between the first argument and the second argument, which is going to be equal to 0, and the alternative will be that it will be greater than 0. Okay, because we are going to specify this in our computation. Alright, so let's go back. So we are supposed to have this, and the paired argument here should be true because we want to look at paired test. Okay, and the alternative should be greater. Okay, so let's quickly run this. Alright, so here we go. So we have the test statistic value, degrees of freedom, and the p-value. You are interested in this p-value. You want to compare this p-value to the alpha level at 5%. Okay, and because this p-value is basically less than the alpha level at 5%, it means that we are going to reject the null hypothesis. Okay, and conclude that the mean record score for group 0 is better when imagery is used. In other words, you can also say that there's enough evidence to indicate that the match pairs difference in the mean record score for group 0 is greater than 0. Okay, now let's assume that the normality test failed. Then it means that you are supposed to make use of the non-parametric test, specifically the Wilcoxon Signed-Rank test. Okay, so let's assume the normality test failed, then we are going to make use of the Wilcoxon Signed-Rank test. So in here, the null hypothesis will be like the median record score for group 0 is the same when imagery is used, and the alternative could be that the median record score for group 0 is better when imagery is used. Okay, so we are going to make use of this function, okay, the Wilcox test function. So we also have to specify the imagery first before the no imagery, then the pair should be true, alternative should be greater. Okay, so let's quickly run this. Control enter. Okay, so this is just a warning message. Let's go to our p-value. Alright, so comparing this p-value to the alpha level at 5%, it means that we are also going to reject the null hypothesis and conclude that the median record score for group 0 is better when imagery instructions was used. Okay, in other words, we can also say that there's enough evidence to indicate that the matched pairs difference in the median record score for group 0 is greater than 0. Okay, so now this is just for one group. This is just for the female group. Okay, now we also have to do the analysis for the male group and look at how the conclusion will be like. Okay, so now let's scroll down. want to determine the average record score for group 1. So here we want to filter A and B for group 1. So I'm assigning my data set to Gen1. So for my new data, I want to filter the gender 1, the label 1, which is for male, okay? And I want to select only these two variables, no imagery and imagery. So let's quickly run this, Control Enter. Then the next thing is to add the difference of the match pairs to the data set, okay? So like what we did for the group 0 is the same thing. We are taking the difference for imagery and no image, okay? So let's run this. Alright, so you can click on here to see the effects. So here we go. So this is going to is giving us the difference. This minus that, this minus that, this minus that, okay? So we have only 11 of them. If you go back to your new data set, you realize that this is for group 1. Yeah, okay. So it's just picking these values for group 1, picking these values. Okay, group 1, all the group 1s. Okay, it's picking these values. So that's what we have here. Okay. Alright, so let's go back to our script file. Alright, so the next thing that I want to do is to test for the assumptions. So here I want to get a KQ plot of the match pairs difference for group 1. Okay, so let me highlight this. Alright, so now my plot is QP1 and my data set is Gen1, and I'm using the variable difference in this data set, and I'm adding the confidence bound line and points and some labels. Okay, so let's run this to see the effect. Okay, Control Enter. Alright, so in here we can see that the points are on the straight line sloping upwards to the right, and we can see that they are also within the confidence bound. Okay, so this is an indication that the distribution of the match pairs difference for group 1 is normally distributed. Okay, we can also rely on other tests like the Shapiro-Wilk test and the Anderson-Darling test. So let's get that. This one is going to give us the Shapiro-Wilk test and the Anderson-Darling test for the match pair difference for group 1. So let's quickly run this. Alright, so we have this p-value for the Shapiro-Wilk test, and this is the p-value for the Anderson-Darling test. Comparing these p-values, you can see that if you have to compare this to the alpha level at 5%, it means that we are failing to reject the null hypothesis, okay, because these are greater than alpha level at 5%. So we are failing to reject the null hypothesis and conclude that the distribution of the match pairs difference for group 1 is normally distributed. Okay, so because this data set also satisfies the normality assumption, it means that you're going to make use of the pair t-test. Okay, so the null hypothesis will be like the mean record score for group 1 is the same when imagery is used, and the alternative will be like the mean record score for group 1 is better when imagery is used. Okay, so let's look at the function. So we specify the imagery first before the no imagery for the group 1 data set. Paired should be true, alternative is greater. Okay, so let's quickly run this. So comparing, look at the p-value. If we have to compare this p-value to the alpha level at 5%, it means that we are going to reject the null hypothesis and conclude that the mean record score for group 1 is better when imagery instructions is used. Okay, in other words, you can also say that the matched pairs difference, there's enough evidence to indicate that the matched pairs difference in the mean record score for group 1 is greater than 0. Okay, alright, so let's assume that the normality test failed, and we are going to basically move to the non-parametric test and make use of the Wilcoxon Signed-Rank test. Okay, so in here we just have to make use of this function, the Wilcox test. So we specify the imagery and no imagery for the group 1 data set. Paired should be true, alternative is greater. Okay, so let's run this. Control Enter. So assuming the normality test failed, then we are going to make use of the Wilcoxon Signed-Rank test. And if you look at this p-value, It means that if you have to compare this to the alpha level at 5%, we are going to reject the null hypothesis and conclude that the median recall score for group 1 is better when imagery instruction is used. In other words, you can also say that there's enough evidence to indicate that the matched pairs difference in the median recall score for group 1 is greater than 0. Okay. Alright, so now that we are done with these two groups, we are now going to look at the analysis for the two groups combined for all the observations. Okay, so now I want to determine the average recall score for both groups for all the observations that we have in our data set. So I'm going to assign my data set to BG. BG is for both groups. So I want to filter 0, that is the female group, and the male group, right? And I want to select only these two variables. So if you look at my new data set, basically what I'm trying to do is to pick only this, pick 1, 0 for these two variables, all of them. Okay, so let's run this, Control Enter. Alright, then we also have to add the difference of the match pairs to the data set. Okay, so let's run this. Okay, so now let me click here. So you can see now it's giving us the difference for all the observations, imagery, no imagery. Okay, sorry, this one is imagery, no imagery. So the difference is in this form. This minus that, this minus that, this minus that. Okay, all right. So the next thing is to basically test the normality assumption. So we're going to start a KK plot. Let me highlight this. So this is for both groups. So I'm using the data set for both groups, and the variable of interest is the difference, and the confidence bound, the KQ line, the points, the labels as well. So let me highlight this and run. Control Enter. So when we combine both groups, we can see that the difference for the match pairs, the points are on the straight line sloping upwards to the right. So this is also an indication that the match pairs difference for all the observations, right, is normally distributed. Okay, let's make use of the Shapiro-Wilk test and the Anderson-Darling test. Okay, for both groups. So let me highlight this, Control Enter. So comparing this p-value, this is the p-value for the Shapiro-Wilk test, and this is the p-value for the Anderson-Darling test. Comparing this to the alpha level or the threshold value at 5% or 1%, it means that we are going to fail. We are failing to reject the null hypothesis and conclude that the matched pairs difference for all observations, right, is normally distributed. Okay, so once we know that all the assumptions has been satisfied, then we can proceed and make use of the parametric test, that's the pair t-test. So here the null hypothesis will be that the mean recall score for all the observations or for both groups is the same when imagery is used, and the alternative will be that the mean recall score for both groups or all the observations is better when imagery is used. Okay, alright, so we are going to make use of the t-test. So in here I'm making use of BG, then I'm interested in the variable imagery first before no image. Okay, then the pair should be true, alternative is greater. Alright, so now let's quickly run this to see the effect. So let me scroll up. So for all the observations or for both groups, we can see that the p-value for this compared to the alpha level at 5% or let's say 1%, it means that we are going to reject the null hypothesis and conclude that the mean recall score for both groups is better when imagery is used. In other words, you can also say that there's enough evidence to indicate that the matched pairs difference in the mean recall score for all the observations, right, is greater than 0. Now, assuming the normality test failed for this kind of data set, then it means that you're supposed to make use of the nonparametric test, right? So we are going to rely on the Wilcoxon Signed-Rank test. So there's a function. Okay. So let's run this. So let me scroll up. So looking at this p-value, let me scroll up and see 0. They are not a little bit different. Okay, they are almost the same, the p-values. So comparing this p-value to the alpha level at 1%, it means that you are going to reject the null hypothesis and conclude that the median record score for both groups is better when imagery is used. Okay, in other words, it comes to say that there's enough evidence to indicate that the matched pairs difference in the median record score for both groups is greater than 0, or for all observations is greater than 0. Okay, so I think we are good to go now. Yep. So this is basically how to perform a detailed statistical analysis for paired samples in R. Please, if you find value in today's tutorial video, don't forget to subscribe if you have not, and also turn on the notification bell to get more updates anytime I post on this channel. Thank you for watching.